Hi there and welcome to another revision video for the Edexcel Core 3 A-level syllabus. In this video we will go through the past paper questions on locating roots and iterative methods. As always, look at a question, pause the video, have a go, and then work through my solutions marking your work. Let's go. Okay, it starts off by giving us this function, and it says that show that f of x is equal to 0, the equation, the function equals 0, can be so rearranged. Okay. We are using the fact that x cubed plus 2x squared subtract 3x subtract 11 is equal to 0. Now, if you're just a bit confused at where to look at, just look. There will be a 3x plus 11 on one side of the equation, and you've almost got that here, but you've got negative 3x subtract 11. So add 3x and add 11 to both sides of the equation, and you would get x cubed plus 2x squared is equal to 3x plus 11. Then looking here, you want to divide by x plus 2. Well, if we factorise the left-hand side, factorise out an x squared, we get x plus 2. Equals 3x plus 11. Then we can divide both sides by x plus 2, and we would get that x squared is equal to 3x plus 11 divided by x plus 2. Finally, we would take square roots to get x, and we're taking the positive square root here, it says for us, and we would get 3x plus 11 over x plus 2. And hence we have rearranged as requested. The next part says that the equation has one positive root, alpha, and it says that this iterative formula is used to find alpha. Take x1 to be 0, find to 3 decimal places the value of x2, x3 and x4. Okay, we want to let x1 equal 0. Now I want to show you how we could do this iteration on the calculator. Here is the calculator. Now unfortunately my emulator is not working currently on my machine, but I can still show you on this picture what to do. In order to solve this, what you would do on your calculator is type in 0 and hit the equal sign. This will then make 0 be equal to your answer. Okay, so just hit 0 and then hit the equal sign. Then, to work out the next iteration, x2, you would type in your calculator the square root, you would make it look exactly like it does here, 3, but you would have aunts instead of x1, instead of 0, plus 11, over aunts plus 2. That's what you would type into your calculator. Probably your calculator requires you to have a square brackets around this. If you type that into your calculator and try and do that now, you would get the following. Your calculator should say the square root of 22 over 2, and you want this to 3 decimal places, so x2 is equal to 2.345. Now the beauty of typing it in like that is all you have to do now is hit equals on your calculator and it will tell you the next one, x3, which if you do that is 2.037, and x4 similarly, one more time hit equals and we get 2.059 to 3 decimal places and we're done. Okay, next part. Show that alpha is equal to 2.057 is correct to 3dp. The method for these is always the same. It's asking you to prove that this alpha is equal to 2.057 is the correct root to the original equation, this original equation, okay, and it's the correct root to 3 decimal places. So what you always do, you always check to the next significant figure. So this is accurate to three decimal places. So you would then check 2.0575, 0.0005 bigger, and then you would check 0.0005 smaller. So you would check 2.0565. Okay, now you're going to put that into the equation, our equation f of x is 0. You're going to put alpha into this equation. You're going to put, the smaller amount into the equation. You're going to put the bigger one into the equation. Hopefully there'll be a change of sign. If there's a change of sign, then there is a root between here, and therefore this is the correct root to 3 decimal places. So we are going to work out f of 2.0565. And remember, f of x is, going back here, our original f of x is x cubed plus 2x squared, subtract 3x minus 11. So if I might just take a photograph of that and just save some time. So there's our f of x up here. So we're going to work out f of this, and we're going to work out f of 2.0575. So I'll leave you a moment to do that on your calculator. Doing that, you get negative 0.014, and for the other one, you get 0.004141. So there is a change of sign. Since f is continuous and change of sign, there's a root between 2.0565 and 2.0575. In particular, therefore, alpha is equal to 2.057 is correct root to 3 dp. And you're done. Next question, pause the video, have a go. Okay, it tells us for the first part, on the same set of axes, draw these graphs. You do not necessarily have to work out the points of intersection. So let's just simply draw these graphs here. Now, you should know root x looks like this. You should know that y is equal to root x looks like that. That's just a given. Now, what does this graph here look like? Well, let's do it in stages. Let's remind ourselves that e to the x looks something like that. Okay? But we're asked to draw e to the negative x. Okay, so e to the negative x actually looks something going like this. But then the graph's been... so the e to the negative x would look something like this. But we're not even asked for e to the negative x, we're asked for the negative of this. So actually, negative e to the negative x would look something like this, crossing at 0, crossing in theory at 0, minus 1. And again, we're not even asked for this. This graph here is negative e to the negative x, but we have to add on 2 to it. So we have to shift this graph up by 1 unit and 2 units. So actually this point here would be at the point 0, 1. And this is tailing off here towards infinity, and this point here is tailing off towards 2. Okay, so we've done part A. Part B then says that given f of x is equal to this, explain how your graphs show that the f of x equals 0 has one solution. Well, if I did let f of x equal to 0, what I'm letting equal to 0 is e to the negative x plus root x subtract 2 is equal to 0, which is if I subtract e to the negative x off both sides and add 2 to both sides, this is the same as the square root of x is equal to 2 subtract e to the negative x. Now I've just drawn the graphs of root x, and I drew the graph of 2 subtract e to the negative x over here. Okay, so this was y equals 2 subtract e to the negative x. And these two graphs, where are they equal? They're equal at one point. So explain how your graphs show that this has one solution. You could say that y is root x and y is 2 subtract e to the negative x cross at one point. At one point. And therefore it's clear, because solving f of x is 0 is equivalent to solving where the graphs are equal, therefore f of x equals 0 has one root. And we're done. C, show that f of x equals 0, the root lies between 3 and 4. Well, our f of x, let's just write down what it was again. Our f of x is e to the minus x plus square root of x subtract 2. And if you want to show there's a root between 3 and 4, you work out f of 3, you work out f of 4. Hopefully there'll be a change of sign, and certainly the graph's continuous, therefore you know that there is a root between them. So I'll give you a moment to type those into your calculator. If you put in 3, you get negative 0.218. If you put in 4, you get 0.018, and therefore change of sign and f continuous. Those two facts tell you that there is a root between 3 and 4. And you're done. Part C says, here is an iteration, and it solves for us f of x is equal to 0. It tells us to take x0 to be 4, write down the values of x1, x2, x3 and x4, and hence find an approximate solution to f of x is 0, given your answer to 3 decimal places. Okay, so we've got xn plus 1 is 2 subtract e to the negative xn squared. Okay, and we're told that x0 is equal to 4. Okay, so let's show you how you do this on the calculator. Remember, my emulator's not working, but basically the first thing you would do on your calculator, so in red I'm writing what you do in your calculator, you would type 4 equals on your calculator. This makes 4 be equal to the answer function on your calculator. To get x1, you would type 2, you would do open brackets 2 subtract e to the power of negative ants, close brackets, and you would type squared. If you type that into your calculator, with a bit of luck, you get the following. So I'll give you a second to do that. So you press 4 equals to make it equal to ants. Then you would open brackets 2 subtract e to the power of negative ants, close brackets, and then you would square the whole thing, and you would get x1 is equal to 3.92707. Then you would, by pressing equals again, you would get x2 is equal to 3.92158. Pressing equals again, x3, you would get 3.92115. And pressing x4, you would get 3.92111. Now, it asked you to find an approximate solution to this to 3 decimal places. At this point here, you can see that no longer are these 3 decimal places moving. Look, they're staying the same, staying the same. So an approximate answer is therefore x is equal to 3.9211, 1 even, to 3 decimal places, 921, to 3dp. You're not asked to prove that's a root or that's correct to 3dp. You're asked to find an approximation, not show that it is a root, but find an approximation, and we have found one. Okay, next question. Pause, have a go. Right, working our way through these, we are asked to show that f of x is 0 can be arranged as follows. Dead easy, let f of x be 0, i.e. let x cubed plus x squared subtract 4x subtract 1 equals 0. Notice, in what we're trying to do, we've got 4x plus 1. We've almost got that here, but if we added 4x plus 1 to both sides, we would get that. So x cubed plus x squared is equal to 4x plus 1. Factorise out the x squared. Divide both sides by x plus 1. And take the positive square root. X is equal to the square root of 4x plus 1 over x plus 1. And you're done. You've shown that. It says this iterative formula can be used to approximate alpha. It said previously that alpha is the root of that equation. So, by taking x1 to be a 1, find 2 decimal places, x2, x3, x4. As always, the calculator here, what you do for the calculator, I'll type in red what you would type in. You would say, press 1 on the calculator and then equals. This would make 1 be equal to the answer function. Then in order to get, here's your x1 is 1. x2, to get x2, you would type the following in your calculator, the square root, and you would bracket the top, 4 ants plus 1 over ants plus 1. So typing that into your calculator, you should get root 10 over 2, which to 2 decimal places is all it's asked for. x2 is 1.58. Press equals again to get x3. Round to 2 decimal places, you get 1.68. Press equals again to get x4, and round to 2 decimal places, 1.70. These are all to 2dp, and we've done. Okay, and then it says, by choosing a suitable values of x in an interval, show that this is correct to 2 decimal places. We always do these the same way. What we do is we're trying to show that alpha is equal to 1.70 is correct to 2dp. So we go to the third decimal place and add 0.005, and we subtract 0.005. So we're going to check 1.705, and we're going to check 1.695. We are going to substitute them into the original f of x. We are going to show that there is a change of sign, and we are therefore going to know that there is a root between these, and the root therefore must be this, accurate to 2 decimal places. So I'll let you type that into your calculator. I'll remind you what f of x was. F of x was the following function, which I'll copy onto the slide we're working on. So typing that in, x is 1.695, you get negative 0.037, and typing in x is equal to 1.705, you get 0.044. So you know, therefore, change of sign, and you know that f is continuous, f continuous, therefore root between 1.695 and 1.705, therefore root is 1.70 to 2dp, and we're done. Next question. Write down a value for x1 for which the iterative formula does not produce a valid value for x2? Justify your answer. Well, what value of x1 would make this whole thing not work? Imagine I picked, for example, x1 to be -1, then the bottom would be 0 and it wouldn't make any sense. So x1 would be -1. This would make denominator 0, and basically can't divide by 0. Can't divide by 0. And that's it, we're done. Next question, pause, have a go, then mark against mine. Okay, going through this bit by bit, here's our function. We are to show that f of x is 0 has a root between 1 and 2. So let's work out f of 1 and let's work out f of 2. Hopefully there'll be a change of sign. Because the function is continuous between 1 and 2, we know we've certainly got a root. So our function is x cubed subtract 2 subtract 1 over x. And we're going to work that out for x is 1. If you substitute x is 1 in here, you get -2. If you substitute in 2 in there, you get that the function is 5.5. Change of sign, you always write the same thing, change of sign, and f is continuous. And this is telling us, therefore, root between x is 1 and x is 2. Simple as that. Part B, an approximation for this root can be found using the iterative formula. By calculating x1, x2, x3, x4, find an approximation to this root. We're told that x0 is 1.5. Remember how to do this on your calculator. Type in 1.5 equals, and that puts it as the answer function. And then on your calculator, to get x1, I would type open brackets 2 plus 1 over ants, close brackets, to the power of a third, where ants is this 1.5. So I would type open brackets 2 plus 1 over ants, close brackets, to the power of a third, and therefore this should give you that x1 is equal to 1.387 to 2 dp. x2, pressing equals again, is 1.396 to 3 dp. x3 is 1.395 to 3 dp, and x4 is 1.395 to 3 dp. The 3 decimal places aren't changing here, so x equals 1.395 is an approximation. Now you're not asked to prove this is the solution, where you would go either side of this value. You're just asked to show or find a solution, so that's how we found it. However, in part C, by considering a change of sign of f of x in the suitable interval, verify your answer is correct to 3 dp. So we think our answer for this problem is 1.395. So we think alpha is 1.395. In order to verify this, we go a little bit up, we go 0.0005 up, so we check 1.3955, and we go 0.0005 down, and we check 1.3945. We work out f of 1.3945. We work out f of 1.3955. Hopefully there's a change of sign there, and since the function is continuous, then you would have a solution. So what was our original function? Remember what f of x was. Let's write it down. It was x cubed subtract 2 subtract 1 over x. So x cubed subtract 2 subtract 1 over x. Put in this for your x. Put in this for your x. Hopefully we have a change of sign. So x cubed subtract 2 subtract 1 over x. And you want to evaluate it at 1.3945. You should get for this negative 0.0053, and for the other one you should get 0.0010, and then you can say therefore change of sign and f continuous, therefore root between 1.3945 and 1.3955, therefore 1.395 is correct to 2dp, to 3dp, even 3dp, and we're done. Question, pause the video, have a go. And by the way, this should read 2x cubed. Right, we are trying to solve f of x is 0, i.e. 2x cubed subtract x subtract 4 is equal to 0. Now what I could do to both sides is I could add x to both sides and I could add 4 to both sides. If I did that, I would get 2x cubed would be equal to x plus 4. Then what I could do is I could divide both sides by 2x. So I would get myself x squared is equal to x plus 4 over 2x. And dividing both the x by 2x and the 4 by 2x, I would get a half plus 2 over x. And then taking square roots, I get the answer I want. And I'm just going to rewrite these the other way around because obviously it doesn't make any difference. And there I go. Okay, then it says this equation has a root between 1.35 and 1.4. Use the iteration formula with x0 is 1.35 to find to 2 decimal places the value of x1, x2 and x3. Well, we're told that x0 is 1.35, and I'm going to write in red what you type in your calculator. In your calculator you would write the number 1.35 and you would press equals. That will store it as the ans function. Then when you're trying to work out x2, this is what you type in your calculator. You would type the square root of 2 over ans plus 1 over 2. You would probably have had to put brackets around those as such. If you do that, that would have been x1 even. What would x1 be? Well, I'll give you a moment to do it. And you should have got root 642 over 18, which to 2 decimal places is 1.41. Pressing equals again for x2, you would get 1.39. And pressing equals again for x3, you would get 1.39. Since the second decimal place is not moving, we have now found an answer, or what we think is an answer, at 1.39 to 2 decimal places. Next, it says the only real root of f of x is 0 is alpha. By choosing a suitable interval, prove that alpha is this, is the correct answer to 3 decimal places. As we always do with these, if we're trying to show this is correct to 3 decimal places, i.e. alpha is 1.392, we would go we would take the upper and lower bound of this, so we would check 1.3925 and we would check 1.3915. We would substitute those into the original f, so we would work out f of 1.3915, we would work out f of 1.3925. Hopefully we're going to get a change of sign, and if we do, we know that that root 1.392 is accurate to 3 decimal places. So, what was our original f? Our original f was the following. So I'm just going to cut this here. So that was our original f. So we're going to work that out at the 2 points shown. So 2x cubed, subtract x, subtract 4. Going to work that out for x is 1.3915, and we get ourselves the following: negative 0.00285. And if we type it in for 1.3925, we get ourselves 0.00777. So therefore we have a change of sign. We know f is continuous. Therefore there is a root between 1.3915 and 1.3925, and in particular therefore alpha is 1.392. We can say with comfort to 3 decimal places. That must be the answer to 3dp. Okay, next question. Okay, as you can see, these are all quite similar now. So we want to show f of x can be written as this, i.e. negative x cubed plus 3x squared subtract 1 equals 0. We can rewrite in this form here. Okay, well, what can I do? Well, the first thing, I know there's going to be a 1 on the other side, so I could add 1 to both sides. So I could write negative x cubed plus 3x squared is equal to 1. Then I could factorise the left-hand side, and let's say I'm going to factorise out an x squared. And that's negative x plus 3 is equal to 1. Or rewriting that a bit neater, that would be 3 subtract x is equal to 1. Divide both sides by the 3 subtract x, and I would have x squared is 1 over 3 subtract x. And taking square roots of both sides, I would get the square root of 1 over 3 subtract x, as required for our 2 marks. Next part, starting with x1 is 0.6, use this iteration to work out x2, x3 and x4 to 4 decimal places. As always on your calculator, for the first one it tells you that x1 is 0.6, type in 0.6 equals on your calculator, and that will make 0.6 be equal to ounce. And then to work out x2, you would type the square root of brackets 1 over 3 subtract ounce, and that will give you x2 and all the following iterations. So therefore x2, using this method, so square root 1 over 3 subtract ounce gives you that x2 is root 15 over 6, which to 4 decimal places rounded properly is 0.6455. x3, just by pressing equals now, would be 0.6517, and x4 pressing equals would be 0.6526. And they are x2, x3 and x4 to 4 decimal places. Part C, show that this is a root correct to 3 decimal places. So we think that the root is alpha equals 0.653. As always, we would check the upper bound of this, which is 0.6535, and we would check the lower bound, which is 0.6525. We would work out f of 0.6525. We would work out f of 0.6535. Hopefully we get a change of sign, therefore we'd have a root. Okay, and our f of x in this case was equal to the following. So all we've got to do is work that out for those particular values, and doing that we would get for the first one, we would get an answer of negative 0.00054, and for the next one you would get 0.0021. You know there's a change of sign, so you state change of sign as always. You state f continuous. Therefore you can state there's a root between 0.6525 and 0.6535, and therefore you can state that the root is 0.653 to 3 dp accuracy. And we're done. Okay, next question, pause the video, have a go. Okay, we need to show for part A, here's our function, there's a root of it between 2 and 3. So we use the change in sign rule, we work out f of 2, we work out f of 3, we show that there's a change of sign, and as this is continuous over that range, over that domain even, then we know there's a root. So, type that in your calculator. Putting in 2, you get 0.386, and putting in 3, you get negative 0.391. Change of sign. F continuous. Therefore, root for 2 less than x less than 3. For x between 2 and 3. And we're done. Part B, here's an iterative formula. It tells us what to start with. It asks us to work out x1, x2 and x3, giving our answers to 5 decimal places. As always with these, we use our calculator effectively. We type 2.5 equals into our calculator. That makes 2.5 be ants. And then to get x1, we would type in ln of ants plus 2 plus 1. Hit equals and keep doing it for all the other x's. So therefore, using this, x1 would be equal to 2.5, so to 5 dp we're going to 2.50408, and the next two, all you've got to do is press equals. 2.50498, and x3, all you've got to do is press equals. 2.50518, and we have got x1, x2 and x3 to 5 dp. Part C says that show this is a root to 3 decimal places. We always do the same thing here. I'm sure you're getting bored of it, but it's the same each time. Alpha is 2.505. That's what we think the root is to 2 dp. And we check the upper bound, and that would be 2.5055. And we check the lower bound, which would be 2.5045. We sub those in to our f. So we work out f of 2.5045. We work out f of 2.5055. We hope there's a change in sign, and therefore there will be a change in the root. Now, what was our f here? Our f was our original function, which I'll just copy over for us. That was our original f, which I could paste here just to help us. Okay, so we type that in our calculator. We work out ln of x plus 2, subtract x plus 1. I'm going to work that out at 2.5045. We're getting ourselves the answer 0.00058, and if we put in 2.5055, we get negative 0.0002. Therefore, we can say change of sign, f continuous, therefore root x is between 2.5055 and 2.5045. Therefore, to 3dp, x equals 2.505 is correct to 3dp. And we're done. Okay, next question. Pause the video, have a go. Right, working through each part, here's our function, and we're trying to find the root at the point A. We know at this point the question tells us that x is equal to alpha. To find an approximation for alpha, you use the following iteration. So let's do part A. Here's our iteration. It tells us what x0 is. It asks us x1, x2, x3, x4 to 3dp. As we always do, and as I've said over and over again, to get this to work on your calculator, type in 2.5 equals. That stores 2.5 in the ans function, and then to get future iterations, for example x1, you would type 2 over ans squared plus 2, and that will get you x1. All you've got to do is hit equals to get x2, x3, x4, etc. So x1 then, doing this, you would get 58 over 25, which is 2.32. 2.32. Hitting equals again, you would get, and writing 0 there for 3 decimal places, you would get 2.372. Hitting equals again for x3, you would get 2.356. And hitting equals again for x4, you would get 2.360. And you're done. Okay, next part, part B. It says show that that is correct to 3 decimal places. Same old stuff over and over again. We're trying to show that alpha is 2.359. So we try the upper and lower bound of this. We try 2.3595, and we try alpha is 2.3585. We work out f of 2.3585, and we work out f of 2.3595, and we show that there's a change of sign, therefore there is a root. Now what is our f here? Let's go back and get our original f, or our function. That's our original f there. So just going to copy that onto the next slide. That's our f. So we tap that into our calculator for these particular values, we should get the following. $2.3585. For this one here, we should get 0.0058, and for this one here, we get negative 0.0014. As always, change of sign. F is continuous, therefore root between x less than 2.3595 and bigger than 2.3585. In particular, therefore, x equals 2.359 is correct to 3 decimal places. Okay, next one, pause the video, have a go. Okay, going through this part by part, here's our function where x is in radians. Show that there is a root in this interval. Make sure your calculator is in radians, and what you want to do is work out f of 1.2, and you want to work out f of 1.3. Hopefully you get a change of sign, and this indicates to you that you have a root. So put your calculator in radians mode, and then we're working out coset. By the way, if you remember, coset is 1 over sine. So this thing here is the same as 4 over sine x, subtract 4x plus 1. Okay, so that's what you're working out on your calculator. So 4 over sine x, subtract 4x plus 1, You want to work that out when x is 1.2. You get yourself 0.49, and if you work it out when x is 1.3, you get yourself negative 0.05, and then you say therefore change of sign f continuous. Therefore you can say therefore alpha is between 1.2 and 1.3, and you're done. Next question. Show that the equation can be written in that form, f of x is 0. So what we want to do, we want to show that this equation here, this function equal to 0, can be rewritten as they've suggested. So I'm just going to copy that over to here. There's our starting point, and we're trying to solve this one equal to 0, and we're trying to find x for that. Well, this tells me that 4 over sine x subtract 4 over x plus 1 equals 0. What can I do? I can add 4x to both sides, so 4 over sine x plus 1 is equal to 4x, adding 4x to both sides. Then I could divide both sides by 4, so this divided by 4 would simply be 1 over sine x. This divided by 4 would be the quarter we're looking for, and I would get x is equal to that, which is what we're after, just the other way around. X is 1 over sine x plus a quarter. And we have rewritten f of x is 0 in the form required. They want us then to use the iterative formula here to work out x1, x2, x3 to 4 decimal places. And we always do the same trick on our calculator. We type in 1.25 as our first answer, and we press equals. That stores it as the ans function. And then to get x1, I would simply type 1 over sine of ans plus a quarter. Obviously making sure my calculator is in radians mode. So I would type in 1.25 equals, then I would type in 1 over sine of ans plus 1 over 4, hit equals, and that would tell me what x1 is. x1 by this method is 1.3038 to 4 dp even. Hitting equals again, we would get x2 is 1.2867. Hitting equals again for x3, we would get x is 1.2917, and we have done what's required for the 3 marks. Okay, and last, by considering a change of sign, show that this is right to 3 decimal places. This is the root. We do the same old stuff. Alpha is 1.291. We check its upper bound, 1.2915. We check its lower bound, 1.2905. We work out f of 1.2905. We check f of 1.2915. We work out their values, and we show there's a change of sign. The function we're considering here is this function here. That's what we're typing into, where cosec is 1 over sine. So this thing here is going to be 4 over sine x, subtract 4x plus 1. So that's our function, and we work it out at the following 2 points. So we have 4 over sine x, subtract 4x plus 1, and we're going to work it out at 1.2905. And we get ourselves the following: negative 0.0004, and if I work it out at 1.2915, I would get myself negative 0.0048. Now just looking at this, there isn't a change of sign, so maybe I've made a mistake. I need to work it out 1.2905, and indeed this should have been a positive number. I just made a tiny mistake there. When I typed that back in, that was a positive number. So we write the usual blurb, namely that change of sign and we say that f is continuous, therefore root x less than 1.2915 bigger than 1.2905, and in particular therefore alpha is 1.291 is correct to 3dp. And there we go. Next question, pause, have a go. Okay, working our way through bit by bit. F of x has a root alpha between 1.4 and 1.45. We just use the change of sign rule. So we work out f of 1.4 and we work out f of 1.45, typing that into our calculator. So we've got 3x cubed, subtract 2x, subtract 6, and we work that out at 1.4, and we get ourselves negative 0.568, and we work that out at 1.45, and we get ourselves positive 0.025, and we can say the usual, we can say change of sign, f continuous, therefore root alpha is between 1.45 and 1.4. And we're done. Part B, show that f of x equals 0 can be written in that form. Well, f of x is 3x cubed, subtract 2x, subtract 6 equals 0. And we want to rearrange it into this form here. So what we're going to do, why don't we add 2x to both sides of the equation and also add 6. So therefore we would get that 3x cubed on the left hand side is 2x plus 6. Then why don't I divide both sides by 3, so that x cubed would be 2x over 3 plus 6 over 3. Tidying that up just before I go further into it, I'm just going to write the 6 over 3 first. I'm going to write that as 2, and I'm going to keep this as 2 x over 3. Then what I could do is divide everything through by x. So I'm going to divide everything through by x, so I get x squared is equal to 2 over x plus 2 over 3, because 2x over 3 divided by x just gives me 2 over 3. And lastly, take square roots and just take the positive square root, so that would be the square root of 2 over x plus 2 over 3, and you're done. Show that with x0 as 1.43, use this iteration to find x1, x2, x3, etc. As always, we always do this, type 1.43 and equals in your calculator. That stores this under the ans function, and then when you're working out x1 and all future ones, you simply type 2 over ans plus 2 over 3, and that will get you x1. And by pressing equals, it will get you x2, x3, and all the future ones. So 1.43 equals, then we press square root, 2 over ans plus 2 over 3, close brackets, and then we would get the following. We would get that x1 is 1.4 to 4dp, by the way, 1.4371. We would get x2, pressing equals again, is 1.4347. x3, just by pressing equals again, would be equal to 1.4355, and we'd be done. And next, part D, choose a suitable interval to show that alpha is 1.435 is correct to 3 decimal places. Same old stuff, alpha is 1.435, we check its upper and lower bound to 3dp, so we check 1.4355, and we check 1.4345. We work out f at those points, and hopefully we get a change of sign. So f of 1.4345 and f of 1.4355, and we work those out. So we have ourselves, our original function going back is 3x cubed minus 2x, subtract 6. So 3x cubed, 3x cubed, subtract 2x, subtract 6. So subtract 2x, subtract 6, and we work that out for 1.4345. And you get yourself negative 0.01, and if you calculate it at 1.4355, you get yourself 0.003, and then you can do the whole, you've got to change of sign, so therefore change of sign, you know that f is continuous, therefore there is a root alpha between 1.4355 and 1.4345, and therefore alpha is 1.435, correct to 3 decimal places, and you're done. Pause the video, have a go. Okay, let's work our way through this bit by bit. There's a fair bit going on here. This curve f of x has a turning point at P. Find the coordinates of P. Well, you know at turning points that dy by dx must equal 0. And or f dash x is 0, or f dash x in particular. Now, here's our function f of x. It is, the first part of it is a u times v type situation. There's our u, and times v, which would be e to the x. So to differentiate this first part would be the product rule. To differentiate 1, well, 1 just differentiates to 0. So in this case here, dy by dx would be uv dash plus vu dash. So our u is 3x, our v is e to the x, u dash would therefore be 3, and v dash would therefore be e to the x. So dy by dx for this function using the product rule, it would be uv dash, so it would be 3x e to the x plus vu dash plus 3 e to the x. And that you could factorize that as 3e to the x, x plus 1. So there is your dy by dx, and you know at a turning point it's equal to 0. So you're going to solve 3e to the x, x plus 1 is equal to 0. E to the x is always bigger than 0, so you get no solutions there. So therefore the only solution is x plus 1 is 0, which gives x is negative 1. If x is negative 1, then substituting back in up here, you would get that y is equal to negative 3e to the minus 1, subtract 1. That would be your y. So the coordinates are negative 1, negative 3e to the minus 1, subtract 1, and that's it. You've done for 5 marks. Okay, next part. F of x is 0 has a root between 0.25 and 0.3. Use the iterative formula here with x0 to be 0.25 to find x1, x2 and x3 to 4 decimal places. Same old stuff here. Type in your calculator 0.25 and then equals. If you do that, it would make 0.25 into aunts, and then to get x1 and future ones, you type in a third e to the negative aunts, and that will get you your x1, your x2, etc. So therefore, what will x1 be? We'll type in 0.25 equals, and then type in a third e to the power of negative aunts, and x1 would therefore be 0.2596 to 4 decimal places, x2 would be 0.2571, and x3 would be 0.2578 to 4 decimal places, and you're done. 3 easy marks. And lastly, choose a suitable interval to show that this is the correct route to 4 decimal places. Same old stuff. X is 0.2576. You think that's the route correct to 4 decimal places. You try its upper bound, which is 0.25765. You try its lower bound, 0.25755. You work out f of 0.25755. You work out f of 0.25765, and hopefully there's a change of sign, and therefore there will be a root, and this will be correct to 4dp. So let's do it. So if we do it, here was our original function, and we're solving f of x equal to 0. We're starting with x is 0.25755. We type that into our calculator, and we get negative 0.00038, and you type into your calculator the same thing but for 0.25765, and you get yourself 0.00011, and therefore the same old thing, therefore change of sign. You know that f is continuous, therefore there is a root between 0.25755 and 0.25765, and in particular therefore x equals 0.2576 is correct to 4 decimal places, and you're done. Next question, pause the video, have a go. Okay, working through bit by bit, it says we've got a curve y is ln 3x, it crosses the x-axis at the point P, P0, sketch the graph of ln 3x showing the exact value of P. Well, just in general, you know that ln x graph looks like this, going through 0, 1, that's a normal y is equal to ln x graph. And you want to sketch the graph of ln 3x, and you want to find this value of P here. The graph of y is equal to ln 3x would be very similar to this, but I'm actually going to rub this out just to avoid confusion. It would be very similar to that, but it would cross here at a third and 0. And that would be the graph y is equal to ln of 3x, and you'd be done. Okay, next part. Okay, we're told that the normal to the curve at Q with x coordinate Q passes through the origin. Show x is Q is a solution of this equation. Well, what can we do here? Well, what we can do is we know that our original equation is y is equal to ln of 3x. And we know that dy by dx, if we differentiate this, would be the differential of 3x, which is 3, over the expression inside the ln, which is 3x, so it would be 1 over x. So dy by dx, the gradient of the tangent at the point x is equal to q would be 1 over q. So therefore, gradient of the tangent is 1 over q. Therefore, the gradient of the normal is its negative reciprocal is negative q. I've put a line down the page here. You should work down the page, not across, but a line down here for easiness of working. Therefore, we're going to use the formula to try and work out the gradient or the tangent of the normal. Y subtract y1 is mx subtract x1, where y1 and x1 are a point on the line, and m is the gradient. Well, we know m is equal to negative q. We also know that a point on the line, it tells us the normal goes to the origin. So x1, y1, they're both equal to 0. So y is equal to negative q times x. And that is the equation of the normal. Okay, so we're nearly there here. We also have an equation y is equal to ln of 3x. Okay, so if we substituted x is equal to q into both of these, for this case y would be negative q squared, and for this case y would be equal to ln of 3q. Now we know they're both equal to y, they both have the same y value, so therefore we can deduce that negative q squared is ln 3, so negative q squared is equal to ln 3q, and adding q squared to both sides 0 is q squared plus ln 3q, i.e. X equals q is solution of 0 is x squared plus ln of 3x, and we're done. Okay, next part, show that the equation in part B can be arranged to the following. The equation in part B is x squared plus ln of 3x equals 0. We want it rearranged in this form here. So what we're going to do is subtract x squared from both sides. We know we want to keep that x squared, so ln 3x is equal to negative x squared. Take exponentials of both sides, therefore 3x must be equal to e to the negative x squared, and divide both sides by 3. X is therefore a third e to the negative x squared, and we're done. The 2 easy marks. And then use this iteration to find x1, x2, x3, and hence write an approximation for this value q. So, as always, we do here, we type in our calculator a third equals, so that ounce is stored as a third in our calculator. To get x1 and future ones, we type in a third e to the negative ounce squared, and that will get us all our x1, x2s, etc. So, x0 is a third, x1 is therefore, so type in a third equals, then we type in a third e to the power of negative ounce squared, and we get ourselves that x1 is 0.298 to 3dp, x2 just by pressing equals is 0.305, and x3 is 0.304, all of those to 3dp, and we've got ourselves the last 3 marks. Okay, next question, pause the video, have a go. Okay, part A says draw the equation y is equal to ln x. An easy graph, you should know what it looks like, and it looks something like this. It crosses at 0, 1, sorry, at 1, 0. It asymptotes to the y-axis, and it tends off towards infinity as x tends to infinity. 2 easy marks. Part B, show that the tangent to this curve at the point E1 passes through the origin. So just going back here, the tangent at the point E1 might be somewhere like here. We're asked to show that this tangent is going to go through the point 0, 0. That's what we're trying to show. Bit of a thick tangent there, maybe we just narrow it down a fair bit there. We're trying to show that this tangent goes through the point 0, 0, 0. Okay, how could we do that? Well, what we could do is work out we know a point on the tangent, we could work out the gradient of the tangent. So if y is equal to ln x, dy by dx is certainly equal to 1 over x. And dy by dx at the point x is equal to e, this point here must be 1 over e. Then using y minus y1 is equal to mx subtract x1, and a point on the line x1, y1 is e1, we could type y subtract 1 is 1 over e, x subtract e, and we could multiply through here, and we could say that y minus 1 is 1 over e, x subtract 1, and we could add 1 to both sides, and we would get that y is equal to 1 over e, x. You should continue down the page and not go across the page, but therefore it goes through the origin, because if our equation is y is equal to 1 over e times x, if I put x is 0, then y is 0, therefore tangent goes through origin. And a nice easy 3 marks. Okay, use your sketch to explain why y equals mx cuts the curve y equals x between x is 1 and x is e if if 0 is less than m is less than 1 over e? Well, I'm just going to call back my original. Actually, I'll just redraw it out here, it's just as easy. Ln x looks something like this. That's the point there, 1, 0. You knew that at the point E1 is 2.7 something, so E1 is this point here. And you knew that that tangent went through that point there. You knew that as a fact. Okay, so we've got that as a fact. It says use your sketch to explain why the line y equals mx cuts the curve y equals ln x between 1 and e. Well, look, anywhere between 1 and e, any tangent here, so any point here, I'll do it in the green line, anywhere between here and here, a tangent now any line y equals mx with an m between 0 and 1, well, that must go through the origin. Okay, these type of lines must go through the origin. But the thing about them is, if m is between 0 and 1 over e, this gradient here had a gradient of 1 over e. So if it's between that, it would be somewhere shallower than that, and therefore it must cut the curve y equals ln x somewhere between 1 and e. Okay, it must cut somewhere there, because it is shallower than the tangent we drew previously, which had equation y is equal to 1 over ex. And that's it. Part C, taking the iteration as follows: calculate x1 to x5, given your answers to 3dp. Type in your calculator 1.86 and equals, and then to get x1, you type in e to the third ounce. Just keep pressing equals to get your x1 to x5. So 1.86 equals, and then you type e to the power of a third ounce, and I would get, for my first x, I would get 1.859. Just press equals again to get 1.858. Press equals again to get 1.858, and press equals again to get 1.858, and press equals again to get 1.857. Okay, in the last part, it says that the root of ln x subtract 1/3 x is alpha. By considering a change of sign over this, show that your answer for x5 is accurate to 3 decimal places. Your alpha from the previous part was 1.857, and what we're going to do, we're going to check the upper and lower bounds. So we're going to check alpha at 1.857. In order to check this is right to 3dp, we're going to check the upper bound 1.8575, and we're going to check the lower bound 1.8565. If our f of x is defined to be ln x subtract a third x, then we simply work out what f of 1.8565, we work out f of 1.8575, hopefully we get a change of sign, therefore we have a root, and it's accurate to the required number of decimal places. So ln x subtract a third x, we're going to work that out for 1.8565, and you get negative 0.00014, and working out 1.8575, you get 0.00065. You've got a change of sign, therefore you have a root, Oh, change of sign. Not only that, you have to state that f is continuous. So there's a root between 1.8565 and 65 and 75. So therefore 1.8 alpha is equal to 1.857 is correct to 3 decimal places, and you're done. Okay, next question. Pause the video, have a go. Okay, working through bit by bit, it says the diagram shows the curve y is f of x. The curve crosses the x-axis at a and b and has a minimum at c. Show the x-coordinate of c is a half. So the minimum obviously occurs where dy by dx is equal to 0, or f dash x is equal to 0. So f of x is therefore, writing in index form, this is a half x to the minus 1, subtract 1 plus ln of a half x. I'm going to differentiate this, work out f dash x. Well, this would be minus a half x to the minus 2. 1 differentiates to nothing, and this differentiates to the differential of a half x, which is a half over a half x. And the halves could be divided off top and bottom. So therefore f dash x is 1 over 2x squared plus 1 over x. Okay, now at a minimum dy by dx is 0, so you're solving negative 1 over 2x squared plus 1 over x is equal to 0. Now you should work down the page, not across, but I'm going to start working across just so I stay on the same page. So you're solving negative 1 over 2x squared plus 1 over x is equal to 0. Multiply everything by 2x squared even. Multiply everything by 2x squared. This times 2x squared is negative 1. This times 2x squared would just be 2x. And 0 times 2x squared is 0. And rearranging this, add 1 to both sides, divide by 2. X is equal to a half is the coordinate. And you're done. Part B, find the y coordinate of C in the form k ln 2. Well, you know that x is equal to a half, so you want to work out f of a half, which is 1 over 2 multiplied by a half, subtract 1 plus ln of a half times a half. Well, this would be, this here, 2 times a half is 1, and 1 over 1 is 1, and 1 subtract 1 is 0, so this would simply be ln of a quarter, which is ln of 2 to the power of minus 2, which, bringing down the negative 2, is negative 2 ln 2. The reason I did that is that the question asked for it in the form some amounts of ln 2, so I kept it in terms of ln 2, and k must be negative 2 in this case. Next part, verify the x-coordinate of b lies between there and there. Looking back at the graph, b is a root, so what we want to do is we want to show that there is a root between these 2 points. So we want to work out f of 4.905, and we want to work out f of 4.915, where f is equal to 1 over 2x, subtract 1 plus ln x over 2. So f of x is 1 over 2x, subtract 1 plus ln x over 2. So you need to work these two things out for this particular function here. And you want to work it out for 4.905. You get yourself negative 0.00096, and you work it out for 4.915, and you get 0.00087. And there you can say the usual, therefore change of sign, therefore root lies between 4.905 and 4.915. And you're done. And show that this equation can be rearranged into this form here. So we're trying to work with 1 over 2x subtract 1 plus ln x over 2 is equal to 0. Well, I want it in this form here, so the best option for me here is to subtract 1 over 2x from both sides and then to add 1 to both sides. So I get ln x over 2 is 1 subtract 1 over 2x. Then I could take exponentials of both sides, so x over 2 would therefore be e to the power of 1 subtract 1 over 2x. And then I could times both sides by 2, so x must be 2e to the 1 minus 1 over 2x, and you've got what you were looking for. And last part, calculate to 4 decimal places the value of x1, x2 and x3. It tells you x0 is 5, so you type in your calculator 5 equals, and then to get all the different values, say for example x1, you type in 2e to the 1 minus 1 over 2 arts, and it will get you all your values. So x1 therefore is, how do you get it? Well, you type in 5 equals on your calculator, and then you type 2e to the power of, open brackets, 1 subtract 1 over 2 aunts, and therefore you get x1 is equal to 4.9192 to 4dp. So x2, just by hitting the equals button, you get x2 is 4.9111, and x3 by just hitting the equals button again, 4.9103 to 4 decimal places, and you're done. Okay, and then just to finish off, here's the last question of these type of topics. So pause the video, have a go. Right, going through bit by bit, the diagram shows the curve y is f of x is this, write down the coordinates of a and b. Well, for, let's do b first, that's when x is equal to 0. When x is equal to 0, you get y is equal to e to the 0 subtract 2 minus 1, and y would be e to the negative 2 subtract 1. So the coordinates of b are therefore 0, e to the negative 2 subtract 1. And at a, well, what's 0 at a? Well, y is 0. Y is 0 here. So to find the x coordinate, you're solving 0 is equal to e to the x subtract 2 minus 1. Add 1 to both sides. 1 is equal to e to the x subtract 2. Take logs of both sides and bring down the x minus 2 power. Log of 1 is 0, so 0 is equal to x subtract 2, and therefore x is equal to 2. Was obvious because if you put 2 in here, e to the 0 subtract 1, well, e to the 0 is 1, and 1 subtract 1 is 0. So the coordinates of a are therefore 2 and 0. 2, 0. 0, e to the negative 2, subtract 1. And we've done. Part B, find in the form f to the minus 1 of x, x to the inverse function, and state its domain. So to start with, we're going to say that y is equal to e to the x subtract 2, subtract 1. We're going to rearrange this to make x the subject of the formula. Add 1 to both sides. Take lns of both sides and bring down the x minus 2 power. So ln of y plus 1 therefore must be equal to x subtract 2. And therefore x must be 2 plus ln y plus 1. Rewriting it in this form, f to the minus 1 of x therefore takes x and it brings it to 2 plus ln of x plus 1. And we're done. Now what is the domain of this? Now the domain of the inverse function must equal the range of the original function. Now we've got the graph of the original function. We should know that what was happening here, because we have e to the x subtract 2 take away 1, the e to the x graph, or something like an e to the x graph, has been shifted down by a unit of 1, so it's asymptoting to y is negative 1. It never touches there. So the range is y is bigger than negative 1. That's the range of this function, so the domain of this function is x is bigger than -1. C, prove that f of x equals x has a root in the interval 3, 4. Well, f of x equals x. Let's just write down what that actually means. F of x is e to the x minus 2, x subtract 2, subtract 1. So e to the x subtract 2, subtract 1 is equal to x. And what I could do is I could subtract x from both sides. E to the x subtract 2, subtract 1, subtract x is equal to 0. Now, what I could do is define a new function g of x to be this e to the x subtract 2, subtract 1, subtract x. And if I work out g of 3 and g of 4, if I have a change of sign for this function, then I know that this here equation has a root in that interval, and therefore this equation has a root in the interval, i.e. f of x is equal to x. So I want to work out e to the power of x subtract 2, subtract 1, subtract x, and I want to work out the value of this at 3. If I do that, I get g of 3 is negative 1.28. If I do that for 4, I get 2.39. I can say therefore, change of sign, g is continuous, therefore root of g in the interval 3, 4, and therefore this means therefore root of f of x equal x in 3, 4. And we're done. And the last part, we are asked to use this iterative formula to find alpha. So the first thing we do is we are told that x1 is equal to 3.5. So type in your calculator 3.5 equals, and then to work out x2, etc., we're working at f to the minus 1 of xn. Well, f to the minus 1 is 2 plus ln x plus 1. It's this here. That's f to the minus 1 of x. 2 plus ln x plus 1. So this really, I should have translated this straight away. E to the x to the n plus 1 is equal to 2 plus ln xn plus 1. So to get x2, we would type in 2 plus ln ans plus 1, and we would keep pressing equals in order to find an appropriate root. So therefore, x2, what is that going to be equal to? Well, we're 2 plus ln, so we type in, 3.5 equals, so that's ans on our calculator. We then type in 2 plus ln ans plus 1, close brackets. x2 is equal to 3.5041. x3, pressing equals, 3.0450 in fact. x4 would be 3.5052. x5 would be 3.5052. So to 3 decimal places, it seems that this is not changing, 3.505 seems correct to 3 decimal places. However, this question is a 5 marker. It's not find these answers, it's also that prove that that is correct to 3 decimal places. So what you need to do, as we've always done in the past, this is what our answer we think is, 3.505. We need to check 3.5055, and we need to check 3.5045. So this here, what equation is this? Well, this is x is equal to 2 plus ln x plus 1, and so going back here, what we're I would rewrite this as 0 is 2 plus ln x plus 1 subtract x, and I would call that a new function g of x. So I'm going to work out g of 3.5045, and I'm going to work out g of 3.5055, and hopefully I get a change of sign, and if I do, I know there's a root. So I'm going to type 2 plus ln x plus 1 subtract x. I'm going to work that out at 3.045, and I get myself 0.00058, and I work that out at 3.5055, and I get myself negative 0.0002, and therefore from these I say change of sign, therefore an f continuous, or g continuous even, we've defined this function to be g, so we would say change of sign, g continuous, therefore root. In this interval, therefore root is 3.505 to 3dp. And we're done. And that's every question that's ever come up on iteration and finding roots using iteration. I hope you found that useful in your revision for Core 3. Thank you for watching.